Om Shri Sai Ram, offering my most loving pranams at Swami's lotus feet. I heartily welcome all the students into their final year of post-graduation, MSc Data Science and Computing. Let me introduce the course code and title of the course that we are going to work together. So this course code is MDSC 302 and its title is Big Data Analytics. Big Data Analytics, and it is a 3 credit theory course. 3 credit theory course. You also have an allied practical lab course along with this, that is called as MDSC 302P, and it's called Big Data Analytics Lab, and that is a 2 credit lab course. It's a 2 credit lab course, but right now we will not look at the lab course. We are going to focus more on the theory part of big data analytics. The key text we have to follow is here. The title of the key text is Mining of Massive Data Sets by Georg Leskovec, Anand Rajaraman and Jeffrey D. Ullman. We also have video courses by the same authors, and it is available on this website called edX, and you may also find them, if I am not wrong, directly on YouTube. And if any of you are interested to follow those video courses, you could use them as well. But I would request each of you to please have either soft copy or hard copy of this text. Will be very easy for us to follow along in the course. Okay, in the beginning we must try and understand this term called big data. If you are doing big data analytics, first let us understand what is this term called big data. Of course, analytics we are going to do throughout in this course, and we will get to this slowly. But one interesting and shocking revelation about this term called big data is that it really doesn't have any formal definition, but it has got intuitive understanding. Now why am I saying that it doesn't have a formal definition? If I ask in mathematics what is a set, I can say that it's a collection of distinct elements. That's quite a formal definition. Whereas in big data, nobody tells us that something greater than say 30 petabytes is big data. If you ask, I mean, yeah, in some scenarios, yes, it's big data. In some scenarios, maybe it's not big data. So there is no such formal definition, that doesn't exist. But what actually exists is an intuitive understanding, and that is the understanding that I would like to pass on, and maybe we can discuss on that. So traditionally, when we write algorithms, how we work on algorithms is by assuming a computational model. And what is the computational model? We have a CPU and we have a RAM, and we know that all the data is available in RAM, which means we are talking about input data. We are talking about the program itself, which is again data which is also part of the RAM, which is available in RAM. Then any temporary memory that is required for the program, people also call it as scratch data. So either way, you can say they're like variables where you want to use them for your computation. And finally, output. So we can produce all this, and life has been simple, and all this have been fitting in our memory, in the RAM. Now what happens when what we have, suppose we talk about input data, let's not worry about program scratch data on output. We can worry about output quite later, but more important right now is what if the input data that we have to work on is outgrowing and is much more than memory. What happens if data size that we have is much more than the available memory? Of course, we have other ideas, like you may say that why don't I use virtual memory and therefore give a appearance that I have more than my physical RAM available. Now, whichever way you put it, the question we are asking is, what if data size increases much beyond all the techniques that you can do on a single node? And that is the clue. So when data does not fit on a single node, what we are going to do is we are going to distribute the data, and therefore we are coming up with what is called as distributed data parallelism computational model. Look at the computational model that we have here. It's a sequential, whether it's sequential program or a parallel program does not matter. What we are looking at is the data, and the data is fitting well within the RAM. Now we are saying data is not going to fit in RAM, and therefore we are going to distribute the data across multiple nodes. And when you want to do this, when you want to distribute data across multiple nodes, you need a different kind of environment. Maybe you also have to look at slightly different pattern of algorithms as well, and therefore we are looking at algorithms which we are trying to fit into this new computational model called as distributed data parallelism. And this is one of the introductory topics that we will be dwelling on for some time. Okay, so we looked at the input and we saw what is the variation in the new environment, and we are coming up with an idea saying that instead of all the data in one single RAM, let us distribute the data across multiple nodes. Okay. The second aspect that we need to discuss is regarding the output. When we talk about traditional algorithms, let us say you want to write a factorial program, then you say if you want to calculate 5 factorial, then we are going to say that is 120. Now that's an accurate result and an algorithm is expected to do that. Okay, now let's talk about a Google search. If we talk about Google search, and based on the search tags that you are given or the search phrase that you have given, we would like to see a number of results. And what we are trying to intend is, we are trying to see if the top results are the most relevant. Now, can we guarantee this? Can we guarantee this? May not happen. There may be different search phrases for which, I mean, many of us would have encountered this, that the search may come up with results that are different from our expectation, which means that it is not an accuracy, it is not an accurate algorithm that we are looking for, but we are looking for an approximate algorithm. Now, what is the meaning of approximate algorithm? Again, it is a definition that we can understand intuitively. How we define approximate for us is that the results are good most of the time. The results are good most of the time. Then we call it an approximate algorithm, and many of us are happy by getting an approximately good result, which internally means that we can use probabilistic models here, and it need not be the traditional kind of algorithm where we are looking only for the accurate answer. Okay, we discussed now regarding input, what is the variation. We also understand with respect to output, what is the variation. Now let's discuss regarding computation. Traditionally, with respect to computation, what happens? The algorithm or the program is sitting on the CPU. This is sitting on the CPU. Now, as the algorithm moves or as the computation proceeds, we keep fetching data into RAM, which means on demand. If I say that if I have an array and if we do a computation with the array, let us say, and as we proceed, if the array is quite large, after what can fit into memory, one of the pages could get swapped and we may get another page from the disk to the RAM, which means that typically we have been fetching data into memory as the computation proceeds. Now, there is going to be a slight shift in this model with respect to big data algorithms. One point to remember here is that we are not talking about the computation model changing within a node. No, within a node, it is still going to operate in the same fashion. But when you look at a larger perspective and look at the wholesome model, there is a slight change. What we are going to do is we are going to bring algorithm or say program to data. See the small change that's happening, and it creates a world of difference. Traditional algorithms, the computation proceeds and computation fetches data into memory, whereas in the larger picture of big data algorithms, we are going to make data stay in a specific node. We don't want to keep moving data. Rather, we are going to move or bring the program to the data. That's the reversal that happens in this new computational model. So that in summary describes what is different with what we are going to call as big data algorithms. One is that we are going to see data is going to be distributed across nodes. We are not going to worry about accurate results, but we are going to more worry about approximate results, and we are going to shift the pattern. We are going to bring the program to data and we are not going to move data around. The moment we describe the big data algorithms with these three aspects, naturally they bring several challenges associated with each of those aspects. When we say distributed data, what is the kind of storage platform we are looking at? Should I look at a parallel file system? Should I look at a parallel file system? Should I look at a distributed file system? Or would a normal traditional file system do? Will this help? Will a traditional file system itself, would that be enough? Or should I talk about RDBMS? Should I use a relational database management system? Or should there be variations of it? Now you can understand the moment we bring up this feature, naturally it brings a lot of challenges with it. And we are going to describe or learn a specific way and a specific platform in this course. The moment we say approximate results, you see that it need not be a traditional algorithm. Instead maybe we can look at probabilistic approaches. So how do I use probabilistic approaches in order to ensure that we get good results most of the time? Can I guarantee this using my probability theory? And that is why all of you have a good grounding already in probability theory. And the last challenge is this really possible? Because our traditional computational model always has been fetching data to the program. Now we are saying, can I take program to the data? Now the answer is yes, and we are going to see some computational platforms. In fact, they are called distributed computational platforms, and in specific we are going to see probably one platform where we are going to work for big data algorithms. So though we started our discussion on the term called big data, effectively we have actually come up with an idea of what is called as big data algorithms. The reason why we did is that this will also give us an understanding of what is meant by big data. So we now have an idea that if big data algorithms are going to be of this new features, then my big data would have such and such features. Okay, now as I told you earlier, there is no clear definition like a mathematical definition. Again, it's a very intuitive understanding, and I guess people have been very poetic with these definitions. So the first thing that comes into anybody's mind when we talk about big data is that there should be probably some huge amount of data. Now when you say huge amount of data, we are not able to say how much is it, and that is where our understanding of this algorithms helps. What we understand is that data probably that is not able to fit into the memory of a single node, and therefore I need to go for a distributed approach. That's it. Okay, so first aspect that people talk about is called as volume, which means that the volume of data is pretty large. Now when I say pretty large, you understand what I mean. The second aspect is what is called as variety. Now when we talk about traditional algorithms, we expect the data in a specific pattern. If you say I want to find the product of two numbers, then we input the two numbers, find the product. If I say factorial, I give an input as a number and we find the factorial. Now what happens with big data algorithms is that not always are you finding everything in a specific format. So you may want to look at what is called as unstructured data. We will discuss each of these. And since you have unstructured, you must obviously have the other two also, which one of it we call semi-structured, the other one we call as structured. Now this is one thing that we are used to working. Suppose you take data that is available in RDBMS, and where specific columns and rows we have the records, and you have specific columns and where you are having some data here. So what we understand here, there is a specific structure to the data, and therefore such kind of data can be called as structured data. Also, if you have a plain file, but in the file you understand that first I have stored the name, then the age, then the salary, and if you have written this in this specific format, we can still say that it is structured, because we know what is the structure of this file. Next, when we talk about semi-structured data, one famous example that everybody talks about is, you can say there is an XML file, and you can actually add many more. If you want, we can talk about HTML files. Now what is the feature here? We are talking about tags. And the text which is present within a tag is being described by the tag, and therefore we kind of understand what the tag represents. But it is not in a total structured format like a DBMS or a specific file format. Instead, it is kind of loosely structured, but then it has a data description. Therefore, you call it as semi-structured. And last one is called as unstructured data. When you say unstructured data, you're talking about free text. And when we say free text, some examples are like we can think of product reviews, and we can think of log file output, etc. So the challenge becomes, how do we analyze not just structured data, but how will we analyze semi-structured as well as unstructured data. Let us move to the third V, which is velocity. Velocity. What do we mean by velocity? So we are looking at rate of arrival of data. That's one way to look at velocity. Let's take a business model like say Amazon, and if you consider the number of purchases that are happening in every second, that's really large. Or say the number of Google searches that are happening, and more importantly in velocity, what we're looking at is can we analyze online? When I say online, what if the velocity or the arrival of data is so fast that we are really not able to store all the records? In fact, we don't need to store all the records, but can we just look for interesting information and analyze the data as it arrives? So here is another challenge that the third V throws up. No, I mean the V's keep increasing year on year, and what I found is that there are few more that get added. People have been really poetic about it. So veracity. So when we say veracity, we are talking about the authenticity of the data. Authenticity of the data. So we have to ensure that what data we get is correct data. And the last one is, all this is useful only if we are able to produce value from this data. So here are the 5 V's of big data. Volume, saying that tremendously large amounts of data. Variety, where we not only have to deal with structured data, but maybe semi-structured and unstructured. And velocity, the rate of arrival of data is quite high. Veracity, we have to ensure that we are receiving correct data. And finally, we have to deliver value from the data. Otherwise, all what we have done may not be useful. So we are coming to concluding this first session, but before that, let's just ask ourselves, is it really true that we are living in the era of big data? So the answer to that is, look at the current economy. Look at the current economy and what governments are pushing. Now, even in India, at least during the pandemic period, you find that there are many more online users. It is suddenly going to go up, and even in general, the economy is trying to push things go online. Governments are pushing things that, there are many applications that come up, many apps that have come up. Many are trying to go paperless. So what does that intend? That I think definitely it's going to increase the volume like anything. And the moment you say that we're going to have increase in volume, different kinds of applications may bring in different variety, and the arrival of data is going to be high, etc. So I think all these things apply. The scenario is changing, and therefore the subject that you're learning for big data analytics is quite relevant. So why I mentioned this point is that we are not doing a study which is not useful at this time, but there may be something that we can produce which is useful to the society. It is a very relevant piece of study. Okay. Apart from all this, I also wanted to mention my personal opinion about why big data. So this is just a personal opinion. Now, though we may say that the amount of data has increased and there is variety of data, etc. We can't deny the fact that it did not exist earlier. I mean, we have had large amounts of data earlier also. We have had variety of data earlier also. But I guess what has changed is perception. Now, moment we saw that such technologies are available, where we are able to analyze large amounts of data, I guess people are looking at everything as data. Let me give an example. Can you believe that uh, you know uh, there are major websites that track mouse clicks on their marketing website, or say they want to track whether advertisements are being seen. So there could be so many things that are being noted now. So what is happening in general is our perception is, can I draw more and more data? It's the same scenario. I think we have been going to online markets and trying to buy things, but now suddenly we are seeing that why don't I gather the mouse clicks? And that's a business model. Using the mouse clicks, can I drive my business model? Now it's going further. I mean, people are saying that they even want to track the eyeball. Can I track the eyeball? I know the moment the thought occurs, I think they want to capture the customer. And so, we can imagine the moment we are increasing the input being taken, and therefore, obviously, the data will increase and the variety will increase, etc. So, and therefore, in my personal opinion, yes, all these aspects are there, but more importantly, it is this thing that is bringing in this new framework uh, as it is. So I hope that we have had a good discussion and understanding to the introduction of what is big data. We looking at what is big data, and what are big data algorithms, and why do we need big data. Right? So I'm hoping that this session has answered these three questions. Let us end this session with a prayer. Om Shanti Shanti Shanti